Hi, here is a brief summary of the video while we go over. So the first part will be dedicated to the creation of the tables and how to create tables and like the format. Then we're gonna go over the select, from, and limit order by statements. Third, we're gonna use substring functions that they allow you to extract strings, numbers, and all functions related to numerical values. Fourth, we're gonna go over joins because joins are really helpful and might be the thing that you will use the most in your data analyst life. They allow you to merge table and obtain what you want at the end. Fifth, we're gonna go over case statements. Case statements are really helpful to divide and sorting one column into broader categories. And sixth, we finally go over subqueries and especially CTEs. What CTE stands for? CTE stands for Common Table Expression, and Common Table Expression allows you to build up a query at the end without creating the temporary table that you will use in your query. First thing first, we're gonna see how to create a BigQuery account. BigQuery is the SQL console I'm using. You can use any other SQL console such as SQLite or MySQL. Doesn't matter, but I use BigQuery as a matter of convenience because it allows me to have 300 credits that are free and 90 days that I can use the console without paying. And otherwise, the payment for the request you are doing on this project will not cost you any cent. So, because we're using just the basic functions of BigQuery. So, how to set up your account? You have to go in first. So, create a project. So, if you don't have a project, go on new project. Here I already have created the Uber Data project for you guys, and then after it gonna appear on the left menu. And I've created two data sets. The data set is shown by a square with dot inside. So the one I'm using is the demo Uber, and I'm using another one which is called the dev Uber. So create one, the one you want to, and these are tables that you will see, and there is another icon for the views, but you will only use the tables, the row tables, and not the views. A view in SQL is in BigQuery is just another SQL object, if I could say, that is extracted from a table if you don't want to use the whole table. How to create a dataset? You just have to go in the three dots and it's create dataset, and afterwards we're gonna create the tables inside dataset by executing the queries inside each of the tabs in BigQuery. So it's quite intuitive. So remember, you have 90 days to complete this project and 300 credits free. So whatever you want, you can. On this table here, we have all the dimensions we are going to create in our tables. The first one is the passenger count dim, which groups the passenger count ID and passenger count, trip distance, rate code, payment type, drop-off location, pickup location, and daytime. We're going to create with the time step coming from the row table. And finally, the fact table will be created from the row table, selecting only some columns. So I put this schema in description. So in this part, we're gonna go over the create statements. So I've written for you create statements for the data model I mentioned in the introduction. So we have so how to use a create statements is really simple. For convenient usage, I rather use create or replace table, because sometimes if the table does exist, we don't know that it will replace the table. So we specify in each part of in each field the string. It is recommended to create the tables before in string and after in the refined tables, like in your data warehouse or in other data sets that you're gonna use really for analytics, to specify the right format, like a var character or a string or number or datetime if it is a timestamp. So here I create all the dimensions that we're gonna use, except for these ones that I want them for to be integer. So we're gonna create two more dimensions. The first one is the rate code dimension, and the second one is the payment type dimension. I mean, we're gonna add a column to each one. So for adding columns to existing tables, we are using the insert into statement. So insert into after we have the table, and we specify over the columns, so in parentheses. So I want to add a 1 on the rate code ID and so forth, and on the second I want to add the corresponding rate code name. So this is followed after the column specified into parentheses with the command values, and that specifies, like, properly and entering input the values that you will enter in the insert into this table. So for the second one, we got an issue because the format of the payment type was set from the row table in integer. So it does not matter, we have to specify it as a string. It was a string, sorry. So we have to specify it as a string in order then to match afterwards. So I'm just changing the integer into strings. Okay, so now we are good, and we can execute the query. All right, so when we see inside the rate code dimension, for example, okay, I have a preview, and we see that we have a rate code name and rate code ID, which is associated. We're gonna have a second rate code ID afterwards by ranking all these rate code ID. It's gonna be random. That the difference is we want to use this field and not this one. So in this part, as I mentioned, we're gonna change the data and dimension. So the first function you see is a row numbering function. Why I use a row numbering function? A row numbering function is basically giving a place and an order to each line. So you can rank by each element of this column. I'm gonna explain it right afterwards, but like if you want to have to divide each element inside a column and is like the same element, you want to know what the rank of each element inside the subcategory is. So this is why we're gonna use this function and give a random number as datetime ID for use this datetime ID as a key for building the the fact table afterwards. So the row fields that are coming from the row table are TPEP pickup date and TPEP drop off date time. So the first function I use is the extract. So you basically use this extract and then mention which part of the datum you want to use and from which field. And you have to specify after each field what is going to be his name inside the table. So I want to extract the hour, the day, the month, the year, and the day of the week for both of these fields. So we're going to execute the query. And when we see inside this query, now we have the timestamp and the integers. So we would like to have a preview on this one, and here we go. So peak hour, peak day, peak month. This is really convenient, and I forgot to mention that these TPEP drop off and TPEP pickup are in UTC, so not local hour. Before going further, I want to explain you what basically is a join. So a join is when you merge two tables in one and you want to pick the elements from one table and associate with the elements of the second table, but using one or other join with not result as the same output. So when you join, it's like join is the short way to name it as a left join, and the left join take for each occurrence of each record of the table all the records that are coming into the second table with the columns that are in the not listed in the first table. So you got at the end a big table with all the records from the first table matching in the second table with the columns associated with. The right join is the same, but starting from the second table to the first table. So here we have the fact table statements. So we basically take all of the columns from multiple tables, so both from the fact table we've created before and the dimension table. So when you are doing a join, you have to assign a letter to the join in order to SQL to know actually what's this field you're joining, because it's gonna hold sometimes the same name. So let's see it in the first case. So we are joining on trip ID and a passenger count ID. So I give like the T letter to the fact table, and I'm left joining with the passenger count dimension named PC on the T trip ID equal PC passenger count ID. So for each occurrences of the trip ID, I want all the passenger count ID to match with this trip ID. And it's going to be the same for basically all the fields are listed in this join. So you can list the joins one after the others, and don't forget just to put semicolon at the end of your query, because it's gonna stop your request. We are going to execute this one in BigQuery. First thing, I have to change the dev Uber to demo Uber, otherwise it's gonna create new tables, which I don't want to. Okay, there, create or replace as any. Okay, so here we have like no matching signatures for argument type, integer to string. So this, be aware that you can only join on the columns are the same format. So that is the issue we are facing right now. because the payment ID is a string. So I have designed new requests for using the function cast that basically converts one format of a column into another. In our case, it's an integer to a string. We are keeping the columns that we want from the dimensions and the fact table, and actually we will be able to make the joins after executing this query. So here we have in the cast function, which is listed, you can see that you have to precise which column you want to cast and as in which format. Eventually you can name it differently with another name, but in our case we're gonna keep the same name. Now we have a typical exercise that was asked to the candidates, the applicants of the data analyst jobs in Uber, and they were asked for each vendor that has at least made 2 rides, what is the time that are elapsed between 2 rides for one vendor. It was previously for 1 passenger. I didn't modify it, but that's the same logic. So what's behind this? First, we know that for knowing the time in between 2 rides, we have to rank for each vendor, so group by for each vendors that have at least 2 rides. So that is what we are doing in this part of the query. So grouping by the vendor ID and having count superior to 1, strictly superior. So that is our same query we're gonna use for finding our vendors that have at least the time elapsed for the vendors that at least made 2 rides. So we're gonna select the vendor ID and the TPP picket datetime. We assume that the TPP picket datetime will be the reference, as we can use the drop-off as well, but just like it's not gonna differ. So one on the other you choose. And what's interesting here, we use the lack function. So what's a lack function? Lack function is a window function that allows us to select the previous row that was ranked in this function. Why it is so important here is because we are for each vendor, for each vendor ID we partition. So they say like for one vendor ID for all these runs on drive, we select one vendor and we rank the drive and we attribute number, so an index to the rank of to the right of the vendor, and we order them by TPP pickup datetime. So it's gonna catch the lack function, the row before, so that we're gonna be able to minus the TPP pickup datetime that was after to make the difference. In that, we can make the subtraction in between each rows. And so we name it as time between 2 trips. And we have this table at the end of the day. So for these 2 questions, I want you to solve 2 problems. So the first one will be to find the total number of trips by passenger count. And the second will be to find the top 10 pickup location based on the number of trips. So how do we proceed? On the first one, we want to find the total number of trips by passenger count. So we want to group by passenger count, so we can count on each passenger count which number passenger count has. So we're gonna proceed like that. So select count the total rows. Select all each time you're counting like the star. Otherwise, you will count on each column, and if this column don't have the same records as the other ones, you maybe don't have the right output. So count always with the star as a total number, and then by passenger count, because we want the passenger count as well, group by passenger count, and we order by passenger count from ascendant order. Remember, when you use order by, it's by default ascendant, and if you want to specify it like passenger count desk for descendant. So for the second problem, we want to we want to count by pickup locations. The thing is, we don't have this field as a precise pickup location. So we have pickup latitude and pickup longitude. So we want to build a new column that will be the concatenation of those two. So how we proceed? We use the function concat with a comma in between for concatenating the pickup latitude and pickup longitude as pickup location. And we want only the top 10. So we're gonna use the command limit 10. So let's execute these queries. So on the first one, we can see that for one passenger, that is the major number of passengers of rides. Sorry. And then after it decreases as the passenger count increases. For the second one, like for the pickup location, there is actually something that is wrong in this because the SQL query doesn't know how to group by this new field. So we got a total number of 1 as each pickup location is counted as different. So we're going to modify this query for answering this question. Did you find out why the query was wrong? It's because we have the pickup latitude and pickup longitude were not strings in the table analytics. So if we look up at the schema, we see that there are floats. So there might be something like as grouping that is going wrong with those two columns. So we must format them as strings. So for this, we use the previous C function casts and for those two fields. So it is gonna be as output concat cast pickup latitude as string. So the same syntax, cast pickup longitude as string as pickup location. So now we can execute the query. And by the way, little tip, you can just highlight your query in BigQuery and just running it afterwards. Okay, so we see right now that the center, so pickup location 00, got the most of trips, and then after it decreases sharply over 21 on this location, and we can actually look for it. What's this in Google Maps? That would be funny. By the way, this Uber dataset has been made from trips in New York, so there might be some location in New York. Yup. Here we are. So this is right in Queens Boulevard in Long Island. I don't know if you are a New Yorker or used to go in New York, but it's right in Long Island City up there. So I really wonder why. It depends on when the data was recorded, but it's fun to see how the rides are located, and I invite you to pin all these locations on the dashboard that you can see right on the map which are the locations that are the most chosen by the user writer. So that must be fun. Hey, if you enjoyed this content, you can hit the like button and subscribe to my channel. If you would like to some extra content about SQL queries, comment and I will review all your comments and create maybe a SQL series that we can go deeper in complex queries. And I'll see you in the next video. Bye!